All right, if you're looking to clean up your collection of photos and videos, find duplicates and create a sane file structure out of them, I put together a quick tool to help out with this, so let's jump in and check it out. So welcome back. After I purchased the Synology, I started to decloudify all of my photos and videos. I realized I had a whole other problem, and that was a total mess of files. And over the years, with many different people using different devices and different cloud service providers, and this is over like a decade or more, there were multiple copies of the same file organized into different file structures, and it made absolutely no sense. When I got the Synology, it was great to have everything at home on one device, starting to bring them out of the cloud, but I found it difficult to still find what I was looking for. Watching Plex grind away at all my duplicate files was, it made me feel bad for it. So I decided to kind of do something about it. And looking back, when I had one or two digital cameras in the house, this was super simple. Remember the days you just download all your files off of the camera, USB, and I could move them into a well-defined folder structure with like year, month, day, describe things a little, and everyone in the house was happy. It was easy to find things. And so, like I said, as time went on, the number of devices goes up, the number of people goes up, and you start to move like cloud service providers, and this started well before things like even like Google Photos existed or iCloud. I eventually just stopped organizing files. I was like, hey, you know what? I don't have time for this, getting it all sorted. And I was like, AI will figure it out someday. We'll come back to that. When I was kind of writing this reminded me of a friend I had who, and this is probably way back in, let's go the early 2000s, had amassed a huge DVD library, and he just bought endless DVDs. He didn't even open them. Like, many of them were still in the plastic wrap. And I used to joke with him that he was totally wasting his time and money by doing this, because someday he'd be able to stream everything. Well, unfortunately, when I look at my streaming bill, or I simply try to use all the streaming services to find something, I'm starting to think he got the last laugh. And also I realized the things I've purchased on streaming services, I don't really own that, but that's for another day. Coming back to kind of my statements around AI organizing our files, our photos, arguably that day is here. I'm not thrilled with kind of the way the tools work, and I just wanted to go back to a simple directory structure I can navigate through without relying on another application and how it categorized people or something else. And if you use Synology Drive or Synology Photos, it seems to do a pretty cool job finding people and tagging them, but that's like yet more work. So you may ask, well, if Synology does it, why did you go write a tool? And basically the answer is I felt like it. I felt like writing some code. I just also felt more comfortable having my own code touch my own data, not knowing what the different tools would do. And I could perfectly control the generated directory structure. I could perfectly control how duplicates were calculated, etc., because I have seen other duplicate detection tools that just look at modification times or something else. And I definitely wanted to use a hashing function for that. So anyway, that is kind of the long and short of how we got here. Let me just jump to the bottom line. This is free. It's on GitHub. The link is below. You can grab the code. If you want to modify it, awesome. If you want to contribute back, that's great. You can also just grab the jar file out of GitHub if you want to play with it. It's yours for the taking. I hope it's helpful. I was having fun with it. But why don't we dive in by walking through how it works? And it really just does two things. It will remove duplicates. It'll duplicate your files. It'll remove duplicates, and it will organize them. And it won't do those two things at the same time. And it always performs those operations with an input and output directory. So it won't do it in place, of course, unless you decide to specify the same input and output directory. Time to write a test case for that. But the idea is it's going to be super safe, and it's going to try to put all changes somewhere else. Again, if you're using this, make sure you have backups, be safe and take precautions. But I tried to make it non-destructive in its files. So, okay. All right, so let's take a look at how this works. And let's start with the organization functionality, which is pretty straightforward. So right here, I have IntelliJ open. We're just going to work out of that. If you download the jar file off of GitHub, you'll need to get Java installed and run it from a command line. But here I have the media organizer jar. You can just start. If you need a command line help, you can just run it with no options. And there you go. So what we're going to do is I made a set of play directories to look at. So let's assume you have a simple directory structure. And so I set up a couple folders here that may look like some media files you have around. And by the way, this is not limited to media files like photos or videos. It'll take any file type. I just happen to use it on photos and videos. So you can imagine you have downloaded a whole bunch of stuff from Google Takeout. You have your iCloud photos. And then maybe you have like some nicely organized photos from years gone by when you had the time to do that. So that's what I've set up here as a test case. And in each of these, I just threw some simple text files, and there are a bunch of duplicates in this file structure. So let's say we want to start by deduplicating this set of input directories. And we're going to tell it, start and look at everything under the input files tree, and we're going to tell it to copy everything to output files. So that is as simple as doing this. And you say, for the action, it's -a, deduplicate, and you can pass a list of input files. So the -i parameter you can pass more than once, but we are just going to do it one time. And it's e:/test input files. Yes. And then -o where you want the files copied to. And that's it. So that will traverse all the files in the input files tree, calculate MD5 checksums on those files, and then it'll go through the resulting, it builds a hash map internally, it'll go through resulting hash map, and it just picks one of the files to copy to the output location, preserving the path of the file. So we'll let it run, and there you go, it's done. You can see in the output files directory, like the iCloud folder isn't there because basically they were all duplicates and the others got copied over. And that's it. That's how it works. Very straightforward. The one thing to remember when you're using the deduplicate functionality is internally, this builds a large hash map, mapping a string representation of the MD5 hash to all the files which have that same hash. And so it can use a lot of memory if you have a large number of input files. And so just be thoughtful of that. So as an example, I ran this on like hundreds of gigabytes of input data, and it was taking several gigabytes of memory, probably 3 gigabytes, which was more than my Synology device has. So to run this on my entire collection on my Synology, I'd actually have to use it to run this over network. I'd have to run this over network file shares, which would obviously be slower, but I need to do it from a computer with more memory. The other thing to remember is, like I said, it's calculating an MD5 hash for every file it reads. That is going to be pretty I/O intensive, so it will take time, especially if you do something like I just said where I was running it all over a network file share. But that's what it does. All right, so the next piece of functionality is the organize functionality, and what it's going to do is, we'll go back to the input directory. The organize functionality basically tries to take your files and organize them into a format that looks similar to what's in this directory. So year, month, day, where it's 4 digits for the year, 2 digits for the month, 2 digits for the day, and then a description of what's happening. And what it's going to do when it organizes files, it's going to traverse the entire tree. If it finds that the path matches that pattern, so if anything in the path matches, say, something like this, it's going to say, that is the folder structure I want to put that file in, and it's going to take it and move it to that folder structure. If it can't find that in the path of the file, so for example, if you look at Google Takeout, this path does not match that date pattern at all. So what it's going to do is it's going to look up the modification time of that file, and it's going to put it in like a corresponding folder of that structure. And so similarly to run that, oh, as an aside, since we can see the output here in front of us, this is using log4j, and if you download the jar, it'll just send the output to standard out. If you want to redirect the output to a log file or something else, you'll need to grab the source code, and the file appender is in the log4j configuration. You'll just need to uncomment it, change the path to what you want, and rebuild the jar file. But it's in there. But just to keep it so it didn't break anyone if they didn't have the right path, I just uncommented the file appender from the released version. So if we want to deduplicate, now I think it's best to run these one after the other. So you've kind of run one pass of deduplication, then you can take the deduplicated files and organize them. So let's just do that. So what I'm going to do is I'm going to grab these output files. I'm going to make a new folder and I'll call it organize input. I'll just paste those in there. I'll make a new output folder, organized outputs. So we'll use those for the organization step. I'll say the action is organize. The input is organize inputs, plural. Then the output is organized output. So we'll run this. And again, really quick because we don't have a lot of data, but you can see in the log what it found and if it decided if it found a matching date format in the path or it used the modification time. That can all be found in the log file along with errors or anything else. Now we can go back, and if we go into the organized outputs directory, here we can see everything is copied over and organized into kind of that year, month, day description directory structure I mentioned before. And like I said, if it couldn't find a matching format, it just organizes them by year, month, and day. It doesn't know the description. This is probably where it used the modification date, and you can see those files in there. Well, that is a quick tour of how to use it. Let me just bring up GitHub real quick. So this project is on GitHub. You're free to grab it. I'll put the link in the description below, and have fun. I hope it's helpful. If you want to modify the code, add other kind of organization techniques, if you want to do different hashing techniques, send a pull request my way and we can work on making it better. But I'll wrap up this part of the video, and what I'm going to do now is jump and we'll do a quick tour of the code if you feel like sticking around for that, if you just want to see a little bit, if it helps you kind of jump off for your modifications. All right, we have IntelliJ open, so let's do a quick walkthrough of the code. By the way, in GitHub, not all of the IntelliJ files are in the repository, so you will need to rebuild that yourself. So let's start, we'll start with main. There's a main function. There's a command line argument processor which sets up kind of all the key objects, but let's just look at one action at a time. So if you choose deduplicate, it really uses just two classes. One is a class which builds the checksums, and then another class which does the deduplication. So we create a checksum builder with the list of input directories. Again, this can be a list with the -i command line arguments. Here you can override the default MD5 checksum function if you want. Apologies for this. I forgot to mention this when we were going through the demos. This does support preview mode, so you can pass in a -p and all file operations will not take place, but you'll still get the log of the actions that will be taken. So if you want to test run this, the preview mode option is there for you. So let's kind of jump into the checksum builder. And we'll just go to the core method, which is calculate checksums, obviously. So what it's going to do is going to go over each of the input directories you provided, and it's going to walk down those paths. It does some like data, some object conversion here, filters out anything which is a directory since we're only looking at files. And basically for each file in the tree it finds, it calls the handle file method, which is here, and this really does all the work. So what we do is we come in, and this is where the checksum function is a lambda, which can be swapped out if you're in preview mode or not. And we run the checksum function. We'll jump down to that in a second. We get an array of bytes back, and we just convert that array of bytes into a string, which is the key to our hash map. And here is the checksum function. We just use the message digest class to get an MD5 instance, and we read 1024 bytes at a time from the file, calculate the MD5 checksum, and send it back. And in the end, so in that process, you're building up this data structure, which is a map of the MD5 hash as a string, and then a list of all the files that have the same MD5 hash. Now, I think it goes without saying, I should have said it before, but obviously this is looking for files that are perfectly identical. If you had two photos that maybe were off by a little bit, you applied some type of editing or metadata, but they're functionally the same, this is not going to catch that, so it's not looking at content. But as we go through the input directories, we're populating this hash map, and that'll help us do the deduplication. That's pretty much it. And then the next thing you do, again in the deduplication workflow, is the deduplicate files class. Similarly, it supports preview mode and just swaps out these implementations with lambdas. And the core functionality is copy and deduplicate files, and this is just iterating over the map we built from the checksum class. And it's really just, this code is pretty much just putting together the output directory, just getting the paths right and set up, and you go through and kind of create the directory structure as you're going and do the file copy. That's it. Now, again, if there was any problem copying the file, we pretty much just log an error and keep going. So this shouldn't crash in the event of like a file copy problem. Similarly, when it's going through and doing the directory creation, you will get an exception if a directory already exists. And so we just kind of swallow that and keep going. Then jumping back to the main class, for the organize functionality, I'm going to create a date organizer. Again, this is an area where I think if you want to work on this, there's probably many other ways to organize files that you could do, and kind of write different implementations of this. Similar pattern with the preview mode supported through lambdas that can be swapped out. And when you tell it to organize files, it's just going to walk through the input directories, calling handle file, a similar pattern. And here, this is where it's going to run the regular expression. So let me jump up. So this is the regular expression that's going to see if the path of the input file matches that year, month, day description pattern. So it's going to run the regular expression on the path. So that's the entire path. And then if we find someone, there's a handler for that. So let's just jump down to that real quick. So since this is the regular expression handler. So here we go. Handle date format match. And what we're going to do is just use the matcher and grab out the year, month, day, and description using the match groups. And then we're going to use those to assemble an output folder name, which we do here using a string builder, and we return that. So that's what happened from that line of code. And basically we get an output directory. We go through and create the directories, create the final path, and copy the file over there. Now in the case that this regular expression didn't match, we're going to go down the path of looking at the modification date of the file. Similar pattern, we just grab the last modified time and build kind of the year, month, day format out of that. Go through the same kind of return path, create the final path, create the output directories, and do the copy. One thing to note here is when we grab the last modified time of the file and then we convert it to a local date time object, we set the offset, the time zone offset, to UTC. So you may find that you could end up with files in slightly different directories if the UTC kind of crosses the time zone boundary. I saw that in some of my testing. Didn't make much of a difference for me, so I kind of left it that way. That's pretty much it. Pretty straightforward. There are unit tests if you want to see more about how things work. And then, like I said earlier, there is a log4j file with file appenders in there if you want to uncomment them for your use. And we'll just jump back to the GitHub. I think that wraps it up. Like I said, this was kind of a fun project for me to help get my files in order. I decided to kind of get my hands dirty and write some code. If it's helpful to you, that's awesome. And if you feel like contributing or changing the code, that would be great too. Hope this helps, and we'll see you next time.